Hi, my name is Alex Beatty, and I'm the designer of the TiltyIMU. When I started this project, I did so because I wanted to build a Segway-style self-balancing scooter. But what started as a single-purpose circuit board, built with parts from Radio Shack and eBay, has since grown hugely in potential to become the idea I'll present to you here. The TiltyIMU has become something new, which will allow anyone to easily build your own self-balancing project, from small-scale robots such as this one, to quadcopters, to a rideable self-balancing scooter, or even something stationary like a self-steadying camera mount or robotic arm. The TiltyIMU works by using this chip, which is a high-end angle sensor, to determine its tilt in any direction. The information from this sensor is then sent to a powerful Teensy 3.0 microcontroller, which plugs directly into the board. All I have to do is plug the TiltyIMU into my computer and run a simple program to see how it sees itself. This demo program mimics the physical motions of the TiltyIMU, whose angle sensor can accurately read the X, Y, and Z tilt angles more than 200 times a second, which is more than enough for most applications. The current TiltyIMU prototype is designed for two-dimensional balance, such as is used in this home-built Segway. Control here is done by leaning the chassis forward and backward, which is sensed by the TiltyIMU. The TiltyIMU then compensates for that lean by moving the motors. And this prototype was built for about $500, which is a lot less than an actual Segway HT costs. And applying this to an aircraft is a simple matter of adding another degree of control. But the real beauty of the TiltyIMU is the fact that it requires no programming. Just some tuning through simple, easy-to-use cross-platform software that will walk you through everything you need to properly balance your project. The software can even save and graph what's going on in the TiltyIMU's processes, so you can better see how tuning affects your project. And with the optional addition of Bluetooth, the TiltyIMU doesn't even need to be plugged into your computer to make changes. And for those with a more specific or advanced project in mind, the Teensy microcontroller used by the TiltyIMU is easily programmable in the well-known Arduino C and C++ languages. This can allow you to easily interface the TiltyIMU with a huge range of additional components. Everything from displays to GPS to additional motors can be hooked up to the extra pins available on the Teensy. But for anyone who wants a bit more freedom of design, there will be a third TiltyIMU variant, designed to be as flexible as possible. Instead of one circuit board with everything on it, the final TiltyIMU version will be several stackable boards, which will allow you to assemble a TiltyIMU perfectly suited to the needs of your specific project. And every TiltyIMU add-on board will have an identifier chip, which will allow the pre-written code to identify what sensors and outputs are available to it. These add-on boards will also be compatible with the other two versions of the TiltyIMU, allowing you to expand their functionality. And this is why I need your help. Everything is already functional, but there's still a bit of room for improvement. And designing and manufacturing circuit boards is expensive. So although the current TiltyIMU prototype is fully functional, I'm aiming to redesign it to reduce both size and cost, and increase functionality. And with more funding, I can develop more add-on boards to expand the TiltyIMU's function even further, as well as go into larger run manufacturing, which will reduce costs. And with your help, we can make it so anyone can easily complete an advanced self-balancing robotics project, thanks to your support and the TiltyIMU.